Okay, so equivalent equations. Now this is a topic that personally I've always found incredibly confusing. And I found it really confusing until I understood really why we're doing it and the meaning of it. Now, you're going to get questions like this, and it's going to say, can you please apply this operation to both sides to make an equivalent equation to this one here? But let's rewind and let's talk about this word equivalence. And if I asked you, where is a time that you've heard the word equivalent? Particularly this year, you're probably going to think of fractions. So let's start with a really easy one, and let's start with 1/2. And I want you to think of an equivalent fraction for 1/2. Now, when we apply an operation in order to make an equivalent fraction, all we do is we do it to the top, okay, the numerator, and the bottom, the denominator. So let's make an equivalent fraction. So an equivalent fraction for 1/2 is 2/4, okay? They both equal a half, they both equal the same thing. They're just represented in a different way, okay? If we've got a pie, for the first one, it's cut in half. For the second one, it's cut into quarters. However, our same contribution is still equal in both of those, okay? So they're equivalent. That's all we're doing here. We're making equivalent equations. So we're going to make an equation that equals exactly the same amount, so m will have the same value, okay? However, it's just going to be like this one here. We're going to cut our pie a little bit differently. So when it says apply this operation to both sides, what that means is that we need to add 10 to the left-hand side and to the right-hand side, okay? So, add 10 to the right-hand side, the left-hand side, that's easy. I just put plus 10. And then here for the right-hand side, I just add 10 because there's already a constant term there, I can add them together. So that's going to give me 20. Now, let's do this. M here, I'm sure you've realised that m equals 5. 2 times 5 equals 10. Down here, let's say that m still equals 5. So 2 times 5 equals 10. 10 plus 10 equals 20. So see how they are actually still balanced. M still equals the same amount, just like our fractions did, but it's just represented in a different way, okay? So when we're talking about equations, they need to be balanced. The whole point in doing this topic is to understand that when we have an equation, so let's just say I've got 3x equals 15, it needs to be balanced on both sides. So remember those old school scales where you would have two balance beams, okay, two balance, and you would put something on this side and then you would add weights to that side until they evened up. And then you would count how many weights are on that side to work out how much whatever the object was that you put on the other side of your scales. It's exactly the same thing. It's exactly the same thing. So here, 3x equals 15. What does x equal? We all know it equals 5. 3 times 5 equals 15. Okay? If I was to add, let's say 15 to both sides, okay, I'd have 3x plus 15. And the reason why I can't add 15 to 3x and make that 18x is because they're different things, okay? This here these are x's, all right? It's a variable, and your 15 is a constant term, so we can't add those together. However, here, these two are like terms, so we can add them together. They're both like terms. So 15 plus 15 gives me 30, okay? And now once again, if x is to equal 5, just like it did on the top, okay, I would do 3 times 5, which gives me 15. 15 plus 15 is 30, okay? So these two equations, okay, they are equivalent equations, okay? They equal the same thing. Now, sometimes you'll be given an equation, let's just say, let's make it simple, let's go x equals 5, okay? And then let's do x plus 5 equals 10. Sometimes you'll be given two equations already, and it will say to you, what has been the change between this equation and the second one, okay? So what has been the operation, like these two operations, that has been applied to turn this one into that one, okay? And if we look at it, it's a giveaway because on here, on this side, we can see that x is by itself, but here it's got a plus 5. And then we can check that. We can look at the right-hand side and we can say, all right, well, here I had 5, but now it's 10. So obviously 5 has been added. So the answer to that would be plus 5, okay? So that's equivalent equations. It's important, really important to understand that equivalent equations are balanced, okay? So we have balanced equations. What we're doing to one side, we do to the other, okay? And this is going to be our segue into solving equations algebraically.